Speed, velocity, or acceleration. I can differentiate between speed, velocity, and acceleration. Your starter. A car travels from point A to C. So here's your car, and it's going from A around the track to C. What is happening to its speed, velocity, and does it have acceleration? So if you look inside the track, it's telling you that the car has a constant speed of 80 miles per hour. So since the speed is constant, we are not changing the speed. So what's happening to the speed of the car? It stays the same, 80 miles per hour. What's happening to the car's velocity as it goes from A to B to C? So its velocity would be changing when it's on the curve because it's changing direction. So here the car's going west, and then as it turns, it's headed south. And then around this corner, it's going to be going east. So you want to look at a compass for the direction when we talk about velocity. So velocity is changing on the curve of the track. Does the car have acceleration? Yes, the car is accelerating because the velocity is changing. The direction is changing. So we say the car has acceleration. Remember, acceleration means to change your speed or direction or both. And here the car is changing its direction. Speed is how fast or slow an object's moving. An example, a person is walking 2 meters per second. It's important to look at your units when you're talking about speed because your units are represented by distance and time. The formula for calculating average speed is speed equals total distance divided by total time. So your formula looks like this. Average speed equals total distance divided by total time. Velocity is speed with a specific direction. The race car is traveling 100 miles per hour west, or the truck is traveling 80 miles per hour east. So here you're going to have your car traveling 80 miles per hour west, so it has velocity, and then the truck is traveling 80 miles per hour east. Speed versus velocity sort. Is the example speed or is it velocity? We're going to drag and drop scenarios into a data table to show our knowledge. So which cards are representing speed and which cards are representing velocity? So 25 centimeters per minute would be an example of speed. A wind-up toy moves 3 centimeters per second. That's an example of speed. 5 meters per second. That's an example of speed. Distance divided by time, an example of speed. Includes the direction an object's moving. Now, when it includes direction, remember that's velocity. The SI unit of measurement is meters per second. That's speed. A girl walks her dog 1 mile in 20 minutes. Speed. Describes how fast an object moves. Speed. Describes how fast an object changes direction. Okay, when we talk about direction, that's velocity. Velocity is speed with a direction. So 20 centimeters per minute north, that's speed with direction, velocity. 5 meters per second, that's speed, but it has a vector giving you direction, so that would be velocity. A plane flies north at 300 meters per hour. So we're given a direction and a speed, so that's velocity. Earth moves counterclockwise around the sun at 30 kilometers per second. 30 kilometers per second is your speed, but you have a direction of movement counterclockwise, so that's velocity. A boy walks his dog 1 mile toward the park in 20 minutes. Okay, so walks his dog 1 mile in 20 minutes. That's speed. Towards the park, it's not really giving you a direction north, west, south, or east. So I suppose it's velocity because we are saying towards the park. A boat travels in the water at 30 miles per hour. So 30 miles per hour is just simply speed, so we can drag that into our speed category. So 2 components of velocity are speed and direction. Speed and velocity are similar because they both describe distance traveled in a period of time. Speed and velocity are different because speed describes the distance traveled in a period of time. Velocity describes a change in position over time because it includes direction. So pretty much velocity has direction associated with it and speed does not. Acceleration. The rate of which velocity changes speed or direction. So, speeding up, slowing down, or changing direction, you would be accelerating. A roller coaster is an example of acceleration because it increases its speed as it goes down the track. It decreases its speed as it goes up. And every time it turns, it's changing its direction. So a roller coaster is changing its direction and changing its speed. So it's accelerating, it's doing both. Acceleration or non-acceleration. We're going to differentiate between speed, velocity, and acceleration. A car travels along a straight bridge at constant speed. This is not an example of acceleration because there's no change in speed or direction because we have constant speed. A football resting on a stand is not an example of acceleration because there's no change in speed or direction. It's at rest. Forces are balanced. A skateboarder coming to a stop is an example of acceleration because the skateboarder is slowing down, so they're changing their speed. A roller coaster on a track is an example of acceleration because the roller coaster is changing its speed and velocity. It's increasing and decreasing its speed. It's also changing its direction, velocity. A swimmer waits on the platform to start a race. This is not an example of acceleration because she's not changing her speed or direction. She's at rest. The forces are balanced. A soccer ball rolls to a stop in the grass. This is an example of acceleration because the soccer ball is slowing down. The soccer ball decreases its speed, so it's accelerating. A runner takes off at the beginning of a race. This is an example of acceleration because the runner is increasing his speed. The runner is accelerating because they're changing their speed. The bee changes directions is an example of acceleration because the bee is changing its velocity, its direction. The graph below is an example of acceleration because the graph shows an object decreasing its speed, so it's accelerating. So if you look at your x-axis and your y-axis, here you know that speed as you go up would increase, but look at your line graph, it's going downward. So we are decreasing speed over time. For your connection, we're going to study each card and recognize whether each is an example of acceleration or not an example of acceleration. We'll drag and drop the cards under example of acceleration or non-example of acceleration and explain why we dropped the card where we did. So, our first card, we're going to classify it as a non-example of acceleration because you know that speed would be increasing here as time would be increasing, but if you look at your line graph, it's flat. So we are not increasing our speed as time goes by. So a flat line is indicating an object at rest. It went a certain speed, then stopped, and then your time is just going by. So this is a non-example of acceleration because your speed is constant, it's flat. This card is an example of acceleration because we know if speed is going up here on our y and on our x, time is increasing. Okay, what we have here on our line graph, we can see increasing speed. So this is an example of acceleration because speed is increasing. So the definitions of speed, velocity, and acceleration are here in the bullets. Speed is traveling a certain distance in a specific amount of time. Don't forget your units are meters per second. Velocity is traveling a certain distance in a certain amount of time in a given direction. This is measured in meters per second. Acceleration is when you're increasing or decreasing your speed. Or acceleration means you change your direction. Or we could do both, changing both our speed and direction. Your units for acceleration are always meters per second squared. So now I would like you to use these bullets to write your own definition for speed, velocity, and acceleration.